So in our previous video, we were able to look at this select curve, best variance, mutual. They will also there are feature selection that for your model. In a situation where you have millions of model, millions of features, that's actually a good idea if you select the best to actually make use of, rather than actually make use of noises in your to train your model. So the next thing we want to actually look at is actually what is actually called that of the train test split. This is actually part of that of the model selection in that of the Scikit-Learn. So just comment this out. We're going to make use of it. So and then I'm going to explain what it actually does. So we can say from our Scikit-Learn, dot our model what underscore selection, we want to import our what train test split. The reason for this train test split is that in this, like I say, train, as you can see, train and this of the test, and then split. What actually this guy actually does is to split your data, so your model doesn't see all the data that you're actually going to. So you can have the one that you are going to use to actually test your model, and one you are going to use to actually train your model. So that's just basically the reason for this train test split. You are going to split your data by the amount of test size you give it. One is going to be, some part is going to be set for that of the training, some is going to be set for that of the testing, and then when you are training your model, you are going to make use of the training. When you are testing, you are going to make use of testing. This is really important, especially when you don't have enough data for testing. You can actually reserve some. So the test data, your model have never come in contact with your test data. That's just basically one of the good thing I like about the train test split. So let's actually see how to implement this. So actually, this is what actually we did in our previous video. So let me just comment this guy out. Let me just copy this. I'm going to make use of this data. Let me just comment. Let me come down. In case if you're interested in all these things that we actually did, like the script is on my GitHub channel. You can actually check it at that of EasyKit. The script is still going to have the name Scikit-Learn tutorial. In case if you want to actually maybe have a handbook or fit everything that we actually did, so you can actually implement it. It's not hard to actually implement actually. So with that being said, now we have our X and our Y. So now we are going to implement that of the train test split. Remember that we have actually imported it up here. So the next thing we want to actually do, when you make use of this train test, which is actually this of the train test split, the first argument you are going to set to it, the first parameter is that of the X and that of your target, and then you are going to set what is actually called the test underscore what size. Or if you don't set it, defaultly is being set to which is 0.25 of your data. This is actually 25% of your data is going to be reserved for testing purpose. That is just basically it. 25% of your data is actually going to be reserved for testing purpose. So what virtual was actually called that of the random. You can set it to any number. You can set it to 42. Most times 42 is being set, but it does not actually do. There's no difference for you setting it to 0, 1, 2, 3. It does not actually do much. So what is using for this random? When you run your script or when you want to train your model, you are going to make use of the train data. And if you want to actually, if you don't set this random model to a random parameter to a value, what you're actually going to do is that anytime you run this script, different set of data is going to reshuffle your data over and over to actually get that one that is going to be used for your training, and that one is going to be used for your testing. So all the time you run it is never going to be the same. So let's say the first time you trained your model and then you run the script again. Let's assume you didn't set this random to maybe a particular value, and then you tested make use of that of the test to actually test data to actually test the model, and then you are getting a different accuracy. on your test. If you run it again, I still get a different accuracy. That can be really not what you actually want at times. Most of the time, just set the random to a particular variable. But if you want to keep on testing to know how well your model actually fit each of the data, maybe when it's being randomized or when it's being shuffled, you can leave it to as default. The default is actually that of the false. So let's actually print this to see our output. So let's actually do print. We want to actually print our train test split. Let's actually run that. So we got an unexpected keyword random. So okay, so this used to be random or state. This used to be random state, not random. Sorry for that. So when we run this, you can see how does it have this kind of messed up? Okay, this is referring to that of the this up is the original data frame, and this was actually what we actually get. Doesn't actually really make sense, but let's actually make this a little bit more let's visualize this. When we run this train test split, it tend to have this kind of output. We have this kind of tuple that you can actually just locate. Let's assume it's going to be something like this. Maybe the input is going to be 1, 2, 3, 4. Remember that if you want to get this output, you can this particular element, you can actually say maybe say something like A is going to target for this of the first. If you set that of the B is going to target for this of the 2. So if you set that of the C is going to target for 3. If you set that of the D is going to target for. So if you print D is going to give you 4. So that is where that we're going to use that ideology to actually get the values that's being inside of this of our train test split. So to do this, next we are going to do is actually what's actually called our S underscore what train. We have the X underscore what test. So this will be underscore, not underscore what. This is going to be test. So you can actually give it a name of your choice. You must give it this name. So the next one is going to be Y underscore what train. And then second one is going to be, so it's going to be Y underscore what test. Simple as you can set it equals to this of our train test split that we have here. The S train, so this will be S. Remember that I can actually give it a name of your choice, but I just want to keep everything. Let me drag this up. I just want to keep everything really simple. So in case if you get to see all this kind of stuff somewhere, you won't actually get confused. So S train, we have this of our X test, and then we have our Y train, and this of our Y text. So let's actually see. Remember that this S train is the feature that is going to be used to train the model. Assuming that this was purely arranged, I should have used this to explain some stuff. So gender, age, I can't even really understand. Everything here is messed up. But let's actually ignore this. So let's actually see the what is going to be used to train our model. Let's actually print this of our S train, because what we are going to train our model with that of the training data set, and then we are going to let's look at our target, which is our Y train. Simple as that. So let's actually make sure that everything actually works is actually okay. Remember that what we actually have here is actually four rows of data. So we're assuming that, why do I keep having this kind of messed up kind of, let's actually go up. Sarah, why is it appearing multiple times? That's not what we actually needed. Okay, gender, color, size. Okay, after this, let's actually try to give this so we know what we're actually doing. So when we look at this is actually referring to our Y train. When I mean our Y, this is our S train. When we look at this, the first remember that what we actually set here, the test size is going to be 25% of our data, and 25% is just actually only one row of data, because what we have here is 4 rows. when we say 50% is actually going to be 2, so I think that actually makes sense. So the other 25 is going to be 1, and the other 25% is going to be 1. So 75 is for the training, testing is just for 25, which is actually just going to be one row of data. So let's actually look at our S-train. This is our S-train. When I mean S-train is the data we are going to feed our model, and this is the targets. This is the target that the model is going to see. So when we give it a new data from what it actually learned from the previous data, it can actually give us a predictive output. So let's actually look at it. The first one we took was actually that of the row 3, which was this of 040, 200,000, which is 040. Where is that? 0 was gender 0, which is gender 0, 40, and 80,000. Remember that everything is being shuffled, but as you keep on running, it is still going to get the same output because of this random state that will actually set the value. If we don't do that, when we run this again, here might be 0, and 3 might not even be. 3 might be falling into that of the test data. So let's actually look at the next one was actually, and then what will actually be mapped to that of the 4. You know that is the 4. Consider this is our target. This is about what our future input that we are going to use to train our model. In case if you want to actually see that of the test, let's actually go down. Let's actually print something like this. So it's going to be our what? Our S. Come on, this will be S. This will be S underscore what test, and then down here we are going to print our Y underscore what test. So let's actually give something. Let's actually maybe give it a line break. So it's going to be this. So we can actually differentiate both of them. Let's actually run it again and see our result. But remember what I actually said here. This is for the training. These guys are for the training. This is the target, and this is for the this is the input feature that the model is going to learn. Then it's going to try to find its best to actually know how it actually relates to that of the target. So let me actually drag this up a little bit so it can actually be big for us to actually understand it really well. So this is what we actually run. So this is our initial data frame. Yeah, this guy is a separate guy initially, but we're going to actually use it to explain something here. So remember that since we set this random to be actually that a value, you can say that no matter how many times I run this, we're still going to get the same output. Remember what we actually got last was this 41 and 302412. We're still going to get the same thing, but we're still going to see what happens when we remove that order. Random state. Actually, not random. That's random state. Actually, so wondering what I do say at times. So let's actually look at this. This is for the training. Yeah, for the training. So this is like saying that of the experience. This is that of the experience side. So it's as if I was saying 412. So we selected this row. Selected this next row. From the look of it, this is it. 1 gender 1 age 3, and then salary 5,000, and then next one was actually this last one 2. So you can see that this row is selected for our testing does not actually exist. So it does not actually exist on our training data. You can see this is what the row which actually row 1, and this row 1 which is actually this guy, it does not exist inside. What actually exists is row 0, 2, and that of the 3. Row 1 never existed. So you can see that even though we use this of the make use of this of the S-train for our training of the model, our model never sees that of the S-test. So these are basically the function of this of the S-test, train test split guide that we actually have here. So what it actually does to split our data into the training and the testing, this is really, really useful. So you can actually, with the help of that of the testing data, you can actually see how well your model is actually performed on a new data, because the model never sees this of the S test and this of the Y test, because it never sees it. It sees it as a new entirely data that you just feed it, and then it's going to try to predict it and give you the output, and then maybe the output result and how it got to predict it. But as we go on, we're still going to see one of the advantage and some of the disadvantage. So train test split by giving it a variable, which is this train test split here, is can be overemphasized, because this actually help you to preserve some data for your testing purpose, rather than feeding your models and everything, and then you don't have the data to actually know how well the model perform. Most of the time, just leave this as 0.25, or if the worst case, if you have a small data, maybe your data is not sufficient enough, you can make this to be 0.2, but never use 10% of your data for testing. May I try to make use of 20% of your data, but it should not exceed 30% of your data. It's all depend on how large your data is. Let's say you have your data is comprised of 1,000 rows, and you made use of test size will be 0.3. That means you're using 300% of your that which is 300 rows for your testing and 700 rows for your training, which is balanced. But in a case you make use of 800 for training and maybe this 200 for testing, is actually really balanced and is actually the best case scenario. But in the worst case scenario, we have like 100 I can say 100 rows of data or 100 data points. The best I can advise for you, don't set it to 10%. Use only 10 for testing and 99 for training. What I can advise for you, go and find more data. That's just the advice. Don't 100 rows of data is not even enough to even for logistics regression is not even enough to actually find the patterns and do a whole lot of other stuff. So try to increase the size of your data, at least 5,000 rows and above. 10,000 rows is okay. Like when you want to do a full-fledged you can say machine learning that you want to use for deployment for public usage, we're looking at 300,000 rows. So from 100,000 rows and above is good. It all depends on the task that you're actually involved with. So if you are doing something like tic-tac-toe game, machine learning AI that is going to help, we can be playing with your tic-tac-toe game. So you know that this is your rows of data or your data point actually has to map to that of all the moves that is available. That's going to be the maximum of your data point. If apart from that, if you add any other things, those are just going to be noise and it's not going to add any other. So the task that you are actually doing actually what actually determines the data that you actually require. Let's say in case you are doing something like maybe you want to figure out, maybe you want to predict, maybe assume something like forest market, or want to predict stock market, you can see that the amount of data that you should be at least more than 100,000 data points. I think that should be one of the minimum requirements. And then with that, your model is going to learn a whole lot of stuff. So talking about learning a whole lot of stuff, that's basically what we're going to do in the next video. We're going to actually use their first ever model to actually predict the data, because we have not actually been predicting it. What I've actually been doing is feature scaling, normalization, feature selection, splitting data for testing and training purposes, and the other things. So in the next video, we're going to actually make use of that of the linear regression. Yeah, that is basically what we're going to. Linear regression, that is going to be the first machine learning model that we're going to use, and the video is going to be splitted into two. First is we're going to make use of Scikit-Learn to actually solve this problem. Secondly, we're going to make use of just normal pen and paper to actually solve this problem. So you can see that some of all this model you can actually solve it by yourself with pen and paper. Only the problem with all these guys, as you go on with higher models like random forest, ML classifiers, all these big guys, it can be prone to error when you are solving it manually. So I think this concludes for this video. Make sure to stay to the next video. We'll be making use of linear regression to solve a particular problem. So I'll be able to see in that video. Thank you for watching.